Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra, the Math 8 edition. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 5.3 on solving systems, we know what that means, of linear equations, we know what that means, by elimination. Hey, what's that? That's a new word. We've already done it by graphing, we've done it by substitution, so this is a third procedure for solving a system of equations. So get ready, get set, let's go. So these are all the steps that are involved, and it's kind of wordy because they have to be complete. So I think if you want to stop and get this in your notes, you can, or if you want to come back and look at it after we do a couple examples, you can. But let's just go by example, and then you can come back and see what we're doing here, to see how this lines up. But let's take a look at this first example here. Solve the system by elimination. Now, this is a real easy example, and I'll explain why in just a second here. I'm going to rewrite the system. X plus 3y equals negative 2, and x minus 3y equals 16. And the reason why this particular example is really easily set up or is easily done using the elimination method is because I have this pair of opposite terms of positive 3y and negative 3y. Because the procedure here is to add these together. How can we add these together, you say? Well, the addition property of equality says I can add the same thing to both sides of an equation and it remains true. Well, the x plus 3y and the negative 2 are the same thing. It says so right here. They're equal. So I can add the negative 2 to the 16 and the x plus 3y to the x minus 3y side, and it will still be true. So let's add these up. I'm going to have an extra step in here just to kind of show you something here. X plus x is 2x. 3y and negative 3y, well, that would be 0y. And then 16 and negative 2 would be 14. Well, 0y, of course, is just 0, and 2x plus 0 is just 2x. So 2x equals 14. All right, so now dividing both sides by 2, x equals 7. All right, so let's take a little pause here. Let's take a look at what we did. Why did we do this? Again, the goal, just like with this, the substitution method, is right here. The goal is to create a single equation with a single variable. Right? So in this case, I just have 2x equals 14. Because that way, when I solve it, I can come up with a number. If I have two variables, I'm always going to have a variable. I'm always going to have the two variables. But since I got rid of one of the variables, I'll come up with that a variable equal to a number. Okay, so now remember that the solution to a system of equations is an ordered pair. So I have to solve for y now. And I can substitute the 7 into either of these two equations. I'm going to use the first one. So x plus 3y equals negative 2. That's the first one here. But now I'm going to substitute the 7 in for the x. So 7 plus 3y equals negative 2. All right, now we're going to solve for y. Subtracting 7 from both sides, I get 3y is equal to negative 9. Dividing both sides by 3, y equals negative 3. So there's my x, there's my y. So the solution to this system is 7, negative 3. Okay, so this was a real simple example, but what happens if it's not so simple? I don't have equations that do this. Well, what are we going to do then? We are going to make that pair of opposite terms. So I'm going to rewrite this pair of equations here. And this is going to require a little bit of kind of creative thinking on our parts as math students. We want to create a pair of opposite terms. So what I'm going to do by examining this, I think the easiest thing here, I can turn a 2 into a 6 by multiplying. And I can turn a negative 2 into a positive 6 by multiplying by a negative 3. And I'm going to do that on both sides of the equation. Everything in the second equation gets multiplied by a negative 3. So negative 3 times negative 2x is positive 6x. Negative 3 times negative 4y is positive 12y. And 14 times negative 3 is negative 42. Okay, so I multiply by negative 3. And for clarification, I'm going to rewrite the first equation down below here so I can get them together so we can demonstrate what we're doing here. All right, so now I put those together. You'll see the 6x and negative 6x equals 0 when I add them together. 12y and 5y is 17y. And negative 42 minus 25 is negative 17. Dividing both sides by 17, I get y is equal to negative 1. Right, so in this case we solve for y first, and now I got to solve for x. And I can solve for it in either one of these equations there. I don't know, I'll probably use the second one because the second one looks, well, they got all these negatives in here, but I don't know if it matters. Negative 2x minus 4y equals 14. So that's the original equation. Now I'm going to substitute the y in with a negative 1. So negative 2x minus 4 times negative 1 equals 14. All right, let's go ahead and simplify. Negative 4 times negative 1 is positive 4. All right, so now subtracting 4 from both sides, I get negative 2x is equal to 10. Dividing both sides by negative 2, I get x is equal to negative 5. All right, so what's my ordered pair for the solution here? Negative 5, negative 1. All right, so negative 5, negative 1. All right, well, that's all I have. There's some more stuff on this lesson, but I want to have a basic video demonstrating elimination method. And this is a little confusing. I'm going to admit this is going to require a little bit of work on our parts to have some creative thinking on how we can make a pair of opposite terms. Anyways, that's it. Thanks a lot and have a great rest of your day. Bye-bye.